Hi, this is Mato from BMI Academy. Here we have some problems before us. I hope you can see this clearly. It says state three characteristics of the image formed by a plane mirror. Okay, so what are the characteristics of image formed by a plane mirror? Let me press space. Hold on. So let's look at that again. A part of the question is asking for the characteristics of image formed by a plane mirror. What are the characteristics? Number one, we have same size as object. When you stand in front of a plane mirror, your image is going to be of the same size as you. Then it's also same distance as the what? Object. Okay, let's talk about the orientation. You're standing upright, your image is also standing upright. So the image is what? Erect or what? Upright. Then let's talk about the nature. The image is going to be virtual. Why is it virtual? Because it is because the image is formed on the opposite side of the observer. You know, if you stand in front of a plane mirror and you are looking into the plane mirror, you are two things at the same time. You are observing yourself, you are the observer. Because you're observing yourself, you're also the object. So the image of you was formed on the opposite side of the observer. Both of you are looking at yourself, both the object and the image. So that makes it what? Virtual. And another thing you need to know is the lateral inversion. Your left-hand side is now to your right hand, to the right hand of your image. So we have that's called lateral inversion. Laterally inverted. As a candidate in the exam, the question just requests you, require you to list three characteristics. So just give any three out of what? Out of the five given here. So in terms of magnification, please, the magnification here is equals to 1. Magnification equals to 1. 1 is called unity. All right. Next question, 4A Roman figure 2. It says, why are convex mirrors used as driving mirrors? Okay, we have convex mirror as driving mirror. As driving mirror. The reason is straightforward. Due to its wide field of view. Now, one disadvantage of convex mirror is that it will always give diminished image. If you remember, the acronym was VED, like for the images formed, virtual, erect, and diminished. Being erect, for the image being erect is an advantage because it's easier to monitor erect images than inverted. But being diminished is a disadvantage. The image is appearing smaller compared to the object. So, but it has a wide field of view. You can, if this is a convex mirror, you can stay anywhere and still see what you want to see. Wherever you are as an observer, let's say this is your eyes here, or this is your eyes here, wherever you are, you can always monitor the image. So that's the disadvantage of using convex mirror as a driving mirror. In fact, it's also the same reason we use it for security purposes in the supermarkets. So the wide field of view is a perfect advantage. Next question for B. How many images will be formed when an object is placed between two inclined mirrors? Sorry, two mirrors inclined at angle 30 degrees to each other. This question falls under inclination of mirrors. That's for B. And the formula for solving that is NI, that's the number of images, equals to 360 degrees over theta minus 1. So in this case, the 360, the theta means the angle of inclination. It gave us the angle of inclination of the two mirrors to be 30 degrees. This is it here, 30. So because it's 30 degrees, we just go ahead and plug it in. 360 degrees over 30 minus 1. So that gives us 12 minus 1. And this is 11. So we have 11 what? Images. The question wants you to find that, and you got 11 images. Next question. The C part of the question, it says in a physics laboratory experiment, a 2-centimeter high diamond ring is placed 20 centimeters from a concave mirror with a radius of curvature of 30 centimeters. Determine the position of the image, its magnification, and its size. So what do you do here? You write down your parameters. Okay. Let's see. So things I need you to know here. The formula, we have what they call mirror formula. It's also applicable to lenses. 1 over U plus 1 over V equals to 1 over F. U there means object, distance. V means image, distance. F means focal length. Now, it is important that you can't just use that formula without convention. Using the formula without convention is an obvious error in your calculation. And what is the what? Convention. Sorry, convention. So the convention is that real is positive. Anything real is positive. Virtual is negative. Please take note of that. Real is once the information is about real image, positive U, positive V. If the information, the object is virtual, if the image is virtual, we have what? V to the what? Negative. So which means V is positive for real. V is what? Negative for virtual. Okay. Another thing you need to know is F. F is also positive for real. F is negative for virtual focus. Okay, while V is obvious, if it is real or virtual, it's obvious. F, you need to understand that concave. Okay, let me do it this way. F is going to be positive for a concave mirror or a convex lens. You get that? F is going to be negative for a convex mirror or a concave lens. So please take note of that. Very important. So now let's go back to solve this problem. What are the parameters supplied in this question? The first thing the question supplied you, sorry, going back there. Another thing you need to know is magnification, please. Forgot to mention that. Magnification is V over U, and the same magnification is equals to VH over what? UH. In some textbook, this thing come with negatives, but you really don't need them. Just know what you're doing. Okay. So the first thing the question gave you here is say in a laboratory experiment, 2 centimeter eye diamond ring. That's the size of the ring. So meaning the image size is 2 centimeter. Image height 2 centimeter. Please, VH means image height or size. U means object height or size. So what the question gave you here is for the objects, right? Moving on. Is placed 20 centimeter from a concave mirror. That's a distance. That's object distance U equals to 20 centimeter, right? So the next, it says concave mirror. Take note of the word concave mirror there. That means it's going to have a positive principal focus, which means positive focal length. Focal length is the distance between principal focus and the pole. So what do we have? They gave us the radius of curvature as 30. So we write that down. R equals to what? 30 centimeter. And don't forget that what R means to F. So this means that your F is equals to 15 centimeter. So let's be specific now. It is plus 15 centimeter. Why? Because it is what? Real. It's a real focus. Now, what does the question want you to do? It wants you to find position of the image. That's image distance. We are looking for U. So what do? You can make use of, we are looking for V, sorry about that. So 1 over U plus 1 over V equals 1 over F. So in that case, we have 1 over 20 plus 1 over V equals 1 over 15. So you isolate 1 over V. So we have 1 over 15 minus what? 1 over what? 20. So what does that mean? That means that, let's see if we could manage our space well. Okay. Hold on. I need more space. Let me just duplicate this. Okay. And take this off. Okay. So we have 1 over V to be equals to that. So what's the LCM there? Can either make use of what? LCM, right? You can use 60. 15 and 60 is 4. 20 and 60 is 3. So we have what? 1 over what? 60. So from there, V is going to be equals to 60 what? Centimeter. Okay. So that means we've answered that question that wants us to find the position of the image. So which means C Roman figure is it? Which means C Roman figure 1 V is going to be equals to 60 centimeter. So that takes us to C Roman figure 2, which is asking for magnification. That's M. So M equals to V over U. Since we have our V as 60, now our U as 20, magnification is equals to 3. So meaning the object is now 3 times its what? The size of the, so I mean that's an error. The image is not 3 times the size of the object. Okay, that's Roman figure 2 part of the question. Then C Roman figure 3. Now I didn't bother to put, you realize that there is no unit for the magnification. The unit is going to cancel out, is a distance over a distance. The last thing the question wants you to find is the size of the image. Okay, size of the image means we are looking for VH, right? So what do? We make use of the magnification. Don't forget that magnification equals to VH divided by UH, right? So from there, my VH is just going to be multiplication, which is 3, times the what? Object what? Object size. And what's the object size? This is it here, which is 2 centimeter. So we have 2 centimeter. So this gives us what? 6 centimeter. So the solution to the 3 things we are looking for are the first one, 60 centimeter. The second one, multiplication is 3. The third one, the image size is what? 6 centimeter. That's quite what? Straightforward.